Good morning, everyone. Today I'll be talking about computer hardware. We'll look at the key parts that make a computer and how they work together to help us use technology every day. Let's get started. On this slide, we will explore the essential components of computers. The first one is Central Processing Unit, which is also known as the brain of the computer, responsible for processing instructions. Memory, or either we can call it RAM. Temporary storage device that holds data for quick access while programs are running. Motherboard, the main circuit board that connects all components and allows them to communicate. Storage device, where data is permanently stored, such as SSDs or hard drives. And last one is GPU, the graphical processing unit. Handles the rendering of images and videos, crucial for gaming and graphic design, etc. Each of these components play a vital role in how a computer operates. Let's explore them further. This is an animation which showcases how the internal components of a computer look like. This is the GPU, the graphical processing unit, the motherboard which holds all of our components together, the CPU, the storage devices, the memory, the power supply unit, and etc. In this slide, I have mentioned the names of each component separately, individually. The case and the CPU cooler, the power supply unit which supplies the power to the whole computer, the memory devices, the RAM modules, the hard drives, solid state drives, the CPU, and etc. Central Processing Unit. The CPU is the brain of the computer which executes instructions and performs various calculations. Key components. Its key components are control units which directs our daily life operations, the arithmetic logic unit which performs arithmetical and logical operations, and the registers which temporarily stores data. Register is a very fast memory which temporarily stores data and it's one of the fastest memories. This animation shows what the internals of a central processing unit looks like. The most upper layer is the heat spreader, the metal package, the integrated circuit, which is also known as die. The die is placed on a printed circuit board, and below the circuit board there are 1200 pins that connect this central processing unit to our motherboard. Let's have a look on the RAM, the random access memory, computer memory that temporarily stores data. RAM is a type of volatile memory that temporarily stores data and instructions that the CPU needs while performing tasks. Here are some key points that the RAM is data in RAM is lost when the computer is turned off, which is why it is used for temporary storage while running programs. Common types of RAM are DDR3, DDR4, and the newer DDR5, each offering different speeds and efficiencies. The capacity of RAM allows computer to handle multiple applications simultaneously and improves multitasking capabilities. That if we can say that if we have more RAM, then we can say that we have more computing power. Overall, RAM is essential for smooth operation, enabling your computer to run applications effectively. The CPU directly communicates with the RAM. Each RAM module has 8 sets of ICs, and each IC has 32 banks in it. Motherboard, the main circuit board of the computer. The motherboard is the main circuit board in a computer that connects all components and allows them to communicate. Here are some key aspects of the motherboard. That CPUs, the motherboard serves as a central hub, like it's the backbone of the computer. It connects CPU, RAM, storage devices, and other peripherals. Chipset. The motherboard contains a chipset that manages data flow between the CPU, memory, and other hardware components. It also has expansion slots and the ports and various connectors. The motherboard is crucial for coordinating the operations of all hardware in a computer, making it a vital component in any system. Here is the animation of the main circuit board of the motherboard. It is a very large circuit board which has various components placed on it, then the CPU sockets, the ports, the expansion slots, then a couple of heat sinks. Under this heat sink, there is the chipset. The chipset directly communicates with the central processing unit and other major parts of the motherboard and manages most of the resources. The secondary storage devices, the devices that which we use to save our data for long-term purposes or permanently. Secondary storage devices are non-volatile storage solutions used to store data permanently even when the computer is powered off. That is, the data stays in it even if the power is turned off. It's non-volatile. It's comparatively it has higher capacity than RAM. RAM is like 16 GB or 32 GB or 64 GB. But the secondary storage devices are very vast, ranging up to 20 terabytes and even more. There are the major types of secondary storage devices that are in use to these days are hard disk, which uses a magnetic technology, the solid state drives, and the USB flash drives. They both rely on the same technology. There are two types of SSDs, the SATA SSD and the later one, the newer one, is known as NVMe SSD. The NVMe SSD is directly connected to the motherboard. Now, this is our magnetic hard drive, which contains a magnetic disk and a motor that rotates the disk up to 7200 rounds per minute. And it has millions of tracks which store our data. The graphical processing unit. Let's take a brief dive into the internals of graphical processing unit. The graphical processing unit is a specialized processor designed to accelerate rendering of images, video, and animations, and it also handles complex mathematical calculations. Its key functions are that it can render videos and 3D graphics. It is also very helpful in gaming for providing better and more FPS, frames per second. Parallel processing, it executes multiple tasks, ideal for heavy workloads. Also, a dedicated GPU can make your computer faster because the integrated CPU is far weaker. The integrated GPU is just enough for giving display. It cannot function and perform other heavy tasks which a dedicated GPU can perform. The integrated GPU is integrated as the name suggests. It's integrated within the central processing unit. On the other hand, the GPU is specialized processor. It's another component that we plug in to the computer. Let's have a look into the graphic cards and its major components. This is the GPU IC surrounded by VRAMs and VRMs. VRM stands for voltage regulators. And above that, we'll have a heatsink which cools down our GPU. It has a couple of ports, display ports, and HDMIs, and the power connectors used to power the graphical processing unit. The graphical processing unit requires a heavy amount of power ranging from 0 watts up to 200 watts depending upon the workload we are putting on it. The GPU's IC is identical to that of CPU, but it's very different. It consists of billions of transistors. That concludes my presentation. Thank you.